Hi, I'm Danny Schlisser. I'm Research and Projects Coordinator in the Friedman Lab at the Arnold Arboretum of Harvard University. So the Tree Spotters program began in 2015 as a part of the Wolkovich Lab here at the Arnold Arboretum. In this program, we train volunteers to collect phenological data from 55 trees on the Arboretum's grounds that represent 11 different species. So they're all native deciduous hardwood trees. Following a 3-hour training session, volunteers will go out on the grounds and collect phenology data from these trees, and we support them with educational materials, monthly events, and all kinds of programs and activities. So Tree Spotters began as a part of the Wolkovich Lab to help collect data that would be helpful for Elizabeth Wolkovich and her graduate students who are studying temperate deciduous tree phenology here in the Northeast. So the program began as a way for them to collect data for their projects, and it is now expanded as a way to create a long-term data set here at the Arboretum with these 11 different tree species that we've selected. So we have two major goals in the Tree Spotters program. The first goal is to create a long-term, high-quality data set that is open and free to use for researchers, the general public, policymakers. So the first part of our goal is really focused on the data collection. And to achieve that goal, we really have to build a robust program with educational opportunities and good training that allows our volunteers to really have a firm grasp of botany and phenology before they go out in the grounds and collect data. The second goal of our program is really to educate our volunteers and really engage them and allow them to experience nature on the Arboretum's grounds, and also to really feel like they're participating in science. So to involve them in citizen science and to teach them the kind of methods and ways of observing the trees out on the grounds. So our expectations for our volunteers are pretty flexible. We allow people to choose how many times they're going to go out and collect data from trees. We allow them to choose which of the 11 species they want to follow. So it's really up to them how much work they want to put in, but we do stress that they are consistent with visiting the same trees so that we can have these long-term consistent data sets. And we really encourage them to start with 1 or 2 trees and really learn the biology of those trees before trying to tackle 3, 4, or 5 species, because it can all add up pretty quickly, as you know. So we also expect them to attend our monthly events as much as they can. We use these events to engage tree spotters and allow them to ask questions and get feedback. And this really helps them build confidence in their observations, and it really helps not only the quality of their data improve, but it helps them get a lot more out of the program, as well as meet other tree spotters and spend more time outside, which I think is good for health. So the data that the tree spotters collect is submitted to the National Phenology Network, which is a large network that collects phenology data throughout the United States, and the program has been around for about 10 years now. But the NPN provides a tool called Nature's Notebook, and this is what our volunteers use to submit their data to the NPN database. So once that data is in the NPN database, it can be accessed by researchers, the public, policymakers, whoever wants to access the data. It's free and open to everyone. And the volunteers can actually visualize their own data. There are a couple different tools that allow them to not only download their data in bulk, but to visualize their data on calendars and scatter plots. So it's really very open and accessible data. And in addition to the data being submitted to the National Phenology Network, the researchers in the Wolkovich Lab continue to use that data as part of their research. So it's serving not only the Wolkovich Lab here at a local scale, but also the National Phenology Network at a much larger scale. And hopefully it's used worldwide, which would be wonderful. So we're just entering our 4th year of data collection now. So we have 3 complete seasons of data collection comprising over 140,000 observations made on the grounds at the Arboretum by our volunteers. So it's a pretty staggering number, and we've really had some wonderful results. We've trained over 400 volunteers at this point. We have a core group of about 60 very active volunteers. It's hard to say definitively anything about climate change from those results, but we do see seasonal variation between our seasons that we've collected data. I was just checking and I saw actually 2 full weeks of difference between flowering time for our birches between 2017 and 2016. So we definitely have data that's showing a lot of variation in the timing of flowering and leaf out and spring phenology especially. Hard to draw any definitive conclusions, but the data is all there and we're really looking forward to going through that data in the next few seasons. So this is a tough question to ask with our trees in particular. Again, it's hard for me to say definitively if we see any difference that's caused by climate change specifically and not just seasonal variation, annual variations in temperature, but it's very possible. In New England, we are seeing lots of phenological anomalies in the last few years especially. We've seen deciduous plants flowering in fall. We've seen some really early springs, extremely warm Februarys and early Marches that have caused plants to start to leaf out. And then cold snaps in March and April, which actually can do damage to those newly emerging tissues. So we are seeing some strange phenology here in New England. And again, it's hard to say whether or not this is due specifically to climate change, but there's a good chance that it is. So compared to Europe, I would say that our deciduous hardwoods up here in New England are probably a lot safer in terms of meeting their chilling requirements each year. However, I will say that, as I mentioned before, things are starting to happen sooner in the season. In spring, we see flowering time and leaf out time happening sometimes in late February, early March. And that can be really detrimental for trees if they then face a late frost in late March or April, which can really destroy some of their tissues. This can have a big impact on agriculture up here in the Northeast. In the past few seasons, we've seen a lot of fruit crops lost, and particularly peaches, plums, and apples that are damaged by these late season frosts after an early flowering phenology. So these early springs can really be detrimental and have a big impact on plants up here in the Northeast. It's hard to say how that plays out in comparison to European species, but I'm definitely interested in learning more about the difference. We have 11 different species, but there's even an amazing amount of variation between those species. They're all native deciduous hardwoods, and yet their flowers, their fruits, and their seeds all look very different. One of our trees, the sugar maple, Acer saccharum, which is an extremely important species up here in the Northeast. It's the main producer of maple syrup up here in the Northeast, and it has beautiful fall color, so a very charismatic tree. It has very interesting flower phenology and morphology. Some inflorescences will have male flowers, and some inflorescences will have female flowers, and yet some inflorescences will have both male and female flowers expressed in the same inflorescence. And it's hard to predict where in the canopy you're going to see the expression of male versus female flowers. So this can be particularly challenging for some of our tree spotters, but we try to teach them about monoecious versus dioecious trees, and for trees that have both male and female flowers on the same tree, or even on the same inflorescence, we try to teach them differences in what they'll expect to see in terms of the morphology and the phenology related to those species. So my message to anyone participating in citizen science is to not be afraid to get out there and collect data and make mistakes. Everyone's going to make mistakes early on. Botany is a very complex discipline that takes years and years to master. So even as a program coordinator, I'm constantly learning about the mistakes that I've made in the past. But because you can go back and edit your data, it's okay to get out there and make a few mistakes. That's how we learn. So I would encourage anyone who's interested in phenology and botany and nature to get out there and partake in citizen science, collect some data, and learn as much as you can as you go.